I welcome you all. Myself Nagarajan, Assistant Professor in EC Department at Rohini College of Engineering and Technology. In this video, we will see about the Anna University third semester subject, that is the EC 8391 Control System Engineering. So this is a syllabus of EC 8391. In this video, we will see about the steady state error constant in the second unit topic. We will solve the one problem. Okay, let us see the problem. The unit feedback system, the open loop transfer function g of s is equal to 10 into s plus 2 divided by s square into s plus 1. Find first part the position, velocity and acceleration error constant, and second part the steady state error when the input is R of s. Here the input is here where R of s is equal to 3 divided by s minus 2 divided by s square plus 1 divided by 3 s cube. So this is a problem. They are given a transfer function system, open loop transfer function g of s, and we need to determine error constant. That is, we have already we studied. We have a three error constant: position error constant, velocity error constant, acceleration error constant. And next, we need to determine that is the steady state error when the input is given. Okay, they are given a input. Now solution, first of all write the given data. So the given data g of s is equal to 10 into s plus 2 divided by s square into s plus 1. Next, unity feedback system, that is the h of s is equal to 1. First part to find, first part, that is a kp, kv and ka, that is a position error constant, velocity error constant and acceleration error constant, that is a kp, kv, ka. And second part is a steady state error, that is a ess. Now first part, we know that that is a position error constant. Position error constant kp is equal to limit s tends to 0 g of s into h of s. So position error constant, we know that formula, position error constant kp is equal to limit s tends to 0 g of s into h of s. We know that g of s value, substitute that g of s value. So kp is equal to limit s tends to 0 10 into s plus 2 divided by s square plus s plus 1. Here we needed to substitute, that is instead of s is equal to 0, we need to, in this limit we needed to substitute, that is s is equal to 0. When the s is equal to 0 means it is a kp value is a infinity. And next, velocity error constant, that is a velocity error constant kv is equal to limit s tends to 0 s into g of s into h of s. We know that that is the h of s value is a unit, so this is a 1. Next, after that, substitute, that is a g of s value. So g of s value, when we substitute, that is a g of s value, and also apply, that is a limit s tends to 0, that is a substitute, instead of 0 replace s by 0. So we will get, that is a infinity value, that is a kv value is a infinity. And next, acceleration error constant, that is a ka is equal to limit s tends to 0 s square g of s into h of s, and substitute, that is a g of s value, and also apply the limit, that is the limit s tends to 0. When we apply that s tends to 0, so we will get, that is the answer is a 20. Okay, so first part is completed. So in this first part, we need to find static error constant value, that is a k. We need to calculate, that is a second part, that is a steady state error. So steady state error, that is a error signal in the s domain. E of s is equal to r of s divided by 1 plus g of s into h of s. Here they are given a input signal, that is r of s is equal to 3 divided by s minus 2 divided by s square plus 1 divided by 3s cube, and g of s value is a 10 into s plus 2 divided by s square plus into s plus 1, and h of s value is a 1. First of all, we needed to calculate that is a e of s value. So when we substitute all the value, so e of s value is a e of s is equal to 3 divided by s into s square into s plus 1 divided by s square into s plus 1 plus 10 into s plus 2 minus 2 divided by s square into s square into s plus 1 divided by s square into s plus 1 plus 10 into s plus 2 plus 1 by 3 s cube, s square into s plus 1 divided by s square into s plus 1 plus 10 into s plus 2. So we determine the e of s value. So our aim is we needed to calculate that is the steady state error. That is the steady state error ESS is equal to limit t tends to infinity e of t. That means that is a limit s tends to 0 s into e of s. So steady state error e of s is equal to limit s tends to 0 s into e of s. Now substitute that is the e of s value, and apply the limit. That is a limit value is a s tends to 0. When we apply the limit, we will get that is the steady state error value. So ess is equal to 1 by 60. So our steady state error value is 1 by 60 for this input. Thank you.